All right, so example number two, big difference between this example and the last example. Now, there's still only one variable. Yes, there's two y's, but that is only one letter. I don't have an x and a y, I just have a y. So I need to figure out what value of y would make both of these sides of the equation equal. I want to end up with an answer that makes both sides, equivalent. It is an equation. But the big difference is last time my variables were on the same side, so I was able to just like combine them, remember? Well, that is not the case here because one of my y's is on the left side of the equation and one of my y's is on the right side of the equation. So I cannot just combine those. Instead, what I have to do is try to cancel off one of the sides of the equation. So I usually try to cancel whatever one is smaller. Uh, Whatever one has the smaller coefficient. So if there's 17y and 14y, I usually try to cancel the one with the smaller coefficient. In this case, would be 14y. So I'm going to subtract 14y on both sides because right here, 14y minus 14y, that cancels. I have to do it to both sides, so I'm going to subtract 14y here. I will get, I can just bring this 6 down, 6 plus 3y equals negative 15. And again, this whole part is gone. It's canceled out. 14y minus 14y is just nothing. From here, I'm in a much better situation because I had y's on both sides of the equation, and now y is only on the left side of the equation. I'm not done yet. Y is not by itself. What I need to do first is cancel out this 6. That is a positive 6, so I can cancel it out by subtracting 6. And if I do it to the left side of the equation, I'm going to come over here and do it to the right side. Cancels there. And I have a 3y is equal to negative 21. I can divide both sides by 3 and figure out that y is negative 7. So what that means is the only time this equation, my original equation, the only time it will actually be equal, the left and the right side will be equal, is if the value of y was negative 7.